A company rents out various sized passenger vehicles according to the following table. For example, a group of 5, 6, or 7, or 8 people would need to rent a sports utility vehicle, which has a total cost of $200. Unfortunately, the total cost to rent a van is missing from the table. In each case, the members of any group equally share the total cost to rent the vehicle. If 4 people rent a car, the cost is. So the cost of renting a car is $180. There's 4 people, so you divide by 4, and that will give you $45. If a group rents an SUV, what is the maximum possible cost per person? So in B, we're talking about $200 being divided by some number. Then the maximum will come if you have the fewest amount of people. And the fewest amount of people in that range is 5. So that will give you 40. When a van is rented, the difference between the maximum cost per person and minimum cost per person is $6. Determine the total cost to rent a van. All right. So the cost to rent would be, well, let's just say this is x. X divided by 9, which would be one cost, and that actually represents the maximum. And then another cost, which is the minimum, would be x divided by 12. Right? You get the maximum minimum with the extreme opposites of the range. So in this case, it's 9 and 12. And they're saying the difference is equal to $6. So basically, that's your equation, and you solve that. So we get a common denominator over here, 9, 9. So 12x minus 9x, and 9 times 12, which is 108, is equal to 6. So 3x is equal to 648, and therefore x would be 216. So this is actually a $216. Trapezoid A, B, C, D has vertices A 0, 0, 12, 0, 11, 5, and 2, 5. What is the area? Let's draw this. So let's see here. We've got 12, 0. So that's 12, and then 11, 5, and then 2, 5. So right here, approximately. And let's connect the dots. And there we go. Probably not drawn to scale, but that's okay. So how do you find the area of a trapezoid? Area is equal to, the first thing is, of course, well, there's a few ways of doing this, but I'm just going to do the standard way. You add this side and that side. So this side is 12, and that side is going from 2 to 11, so that's 9. And then you divide that by 2, and then you multiply by the height. And the height in this case is the y-coordinate, which is 5. So that, when you do that math, it comes to 52.5. The sides the line passing through B and D intersects the y-axis at point E. What are the coordinates of that? Okay, so the line passing through, where was B anyways? This was B, I think, right? And then this was C, and this was D right here. So the line passing through B and D, so I'm assuming this line right here, it crosses the y-axis. Okay, so basically they want this point right here, that point right there. Okay, no problem. Let's see what I can do. Well, the equation of any line is y equals mx plus b. We know that. And we have 2 points on this line. We have this point, and we have this point, b, which is 12, 0, I believe. So just plug those in. So when you do, we get 5 is equal to 2m plus b, and we get 0 is equal to 12m plus b. So then it's just basically solving these two equations. If I subtract them, I'll get 5 is equal to minus 10m, and then therefore m is equal to negative a half. Sub that back in, and with a point. So let's just use, it doesn't really matter which you use. Let's just use this point. So that means 5 is equal to negative 1/2 times 2 plus b. And looks like that means b is equal to 6, right? So that means this equation is y is equal to negative 1/2 x plus 6, the equation of that line. And this point is when the x-coordinate is 0. So when x is 0, y would be 6. So therefore that point looks to me like it's 0. 6. The sides AD and BC are extended to intersect at point F. Determine the coordinates of F. So let's draw this again, and let's see what we get here. We've got this kind of scenario, something like that, right? Not drawn to scale. But then what they're saying is that these two lines are extended. So this line is extended, and this line is extended. And of course, they want you to find that point right there. Okay, so same thing, same big long song and dance here. We got to, find the equation of two lines. And then we have to then find their intersection point. Okay, so where do you want to go here? Well, this is given F. Okay, so line AF, let's do that first. Again, y is equal to mx plus b. And let's just plug in the points. You guys remember the points, right? So this is 0, 0. So that means that b is 0. This point A is 0, 0. So since 0, 0 is on the line, that means b is 0. So that means that y is equal to just mx plus b. Mx, just mx. And if you plug in point D, which I believe was 2, 5, you'll get the equation. So that means when y is 5, x is 2. So that means m is 5 over 2. So that means AF has the equation y is equal to 5 over 2x. And very similarly, we'll find the equation for BF, the other line. And I really think you guys should do that. I mean, if you're in grade 11 and you don't know how to figure out the equation of a line, that's pretty pathetic. So I'm going to just give you the answer. It's 5x plus 60. And I've even done it once, or more than once, actually. All right, so then what you do is just let those two equal to each other. So 5 over 2, as x is equal to minus 5x plus 60. And solve that equation, which I am certain you can do, right? So when you do, you get x equal to 8, and then sub that 8 back into any one of these equations. And when you do, you get y is equal to 20. So the F coordinate is 8 and 20. Determine all possible points P that lie on the line passing through BD so that the area of PAB is 42. All right. So again, let's just draw that a diagram, and whatever, it's something like that. We have A, B, C, D. And then we've got this line B passing through B and D, okay? So this is some line that's like this, and there's a point on it called P, okay? And when you get that point and form this triangle, its area is 42. Now I'm just trying to think, where should I put that P? Does it say anything about where you're supposed to put it? That lie on the line. It just says it lies on the line. Okay. Well, I had a little bit of information. This is 12, right? And this point we had figured out as 6. So this triangle here, let's just see what that area is. It would be 1/2 base times height, 6 times 12, which is really 3 times 12 is 48. So P can't be out here because that would make the triangle have an area greater than 48. So I'm assuming P is somewhere inside. So I don't know where it is, but let's say that's P. So therefore our triangle is really like that. Okay. And I think there's another scenario also, but let's just figure this one out first. Okay. All right. So P is going to have coordinates x, y. So therefore the area of that triangle, PAB, is basically going to be 1/2 base, which is 12, times height, which is y. So it's really just 6y. Correct? And then they've told me that it's got to be 42. So that means y has to equal 7. And we already figured out the equation of this line right here. In a previous question, we had figured it out that it was y is equal to minus half x plus 6. So if you plug in y is equal to 7 there, and solve, you'll get x is equal to minus 2. So that means that coordinate P is minus 2, 7. Great. But I believe there's one other scenario, and that is that this line can be extended this way. And if it is extended that way, then the P could be somewhere here. And that would mean PAB would be like this guy right there. You see, a little bit tricky there, huh? Okay, so how do we do that? Same kind of story, I think, that if P is XY, then again, the area of triangle PAB would be 1/2 base times height. The base is this guy, which is still 12, and the height is from there to there, which is, again, the y coordinate. So it's the same thing. But we have to just use our common sense and say it's not going to be 7 because it's below the x-axis. It's -7. Is that right? Yeah. And that's just looking at the diagram. That's not from mathematics. So we just have to keep that in mind. And then plug it back into this equation, and you'll get an x-coordinate of 26. So this P right here is 26 minus 7. And that completes part D. Sequence with terms a1, a2, a3 is defined by an is equal to 2 to the power of n. Sequence B with b1, b2, b3, so on, is defined by b1 is 1, b2 is 1, and bn is equal to bn minus 1 plus 2, bn minus 2. All right, so what are the fifth terms for each sequence? Okay, so the fifth term for this guy would be a5, and that would be 2 to the power of 5. Correct? So that is, I believe, 32. Correct? All right, so then the fifth term for B, that's going to be B5. It's going to take a little bit more work there. Well, B1 they gave us is 1. B2 they gave us is 1. B3, according to this definition, would be B2, which is 1 plus 2 times B1. And that math gives me 3. And then B4 would be B3, which is 3 plus 2 times B2, which gives me 5. And then B5 would be B4, which is 5, plus 2 times B3, and that looks like 11. So B5 is 11. And if you follow that, you'll get, I don't know if this is required, but you can just do that. B6 ends up becoming 21. B7 is 43. B8 is 85. B9 is 171, and so on. I think B10, we'll do one more. B10 is 341. So I'm just using this formula again and again to figure out the different B's. So what do they want? Fifth term, so we got that was 32 for A5, and B5 was 11. Okay. And moving right along for part B. For some real numbers P and Q, Bn is P times An plus Q times -1 to the power of n. What are the values of P and Q? Okay. So this is my equation this time. So let's figure out what is B1. That would be P times A1 plus Q times -1 to the power of 1. Okay, so what was A1 again? A1 would have been 2 to the power of 1, which is this 2, I believe. Okay, so that'd be 2P, and this looks like -Q. Okay, so that's B1, I believe. 2P plus -Q. And B1, I can actually even plug in B1. B1 I know is 1. That's given in the question, actually. Upstairs here. Right there. B1 is 1. Okay, B2 is 1, so that's good. Let's just use this formula again to figure out B2, and then hopefully that should be enough. Okay, so B2 would be P times A2 plus Q times -1 to the power of 2. Okay, B2 is 1. A2 would be 2 to the power of 2, which I believe is 4. So that's 4P, and this is just going to be Q. All right, so we got two equations. Here's my first equation. Here's my second equation, and I can solve since I have two variables. If I subtract them, or if I add them, it doesn't really matter, whichever way you want to do this. Let's add them. I get 2 is equal to 6p, and therefore p is 1/3. And if I substitute that back into either of those equations, I can calculate my q, and it'll be negative 1/3. And I think that's all they wanted. Just they wanted the values for p and q, and that solves it. Let Sn be the sum of the first n terms in sequence B. That is, Sn is b1 plus b2, ... until bn. Determine the smallest positive integer n that satisfies Sn is greater than or equal to 16 to the power of 2021. Okay, so let's just write down some of the definitions first to remind us what they had given me. That an is 2 to the power of n. I don't think that's even required. And then bn is 1/3. Well, actually, it was p times an. I believe it was minus. That's right here. Let me just see. Yeah, well, sorry, it was plus q times negative 1n. But in the previous question, we figured out the values for p and q. P we figured out was 1/3. So I'll just put 1/3 an. And q we figured out was, I believe, negative 1/3. Yeah. And then so negative 1 to the n. Okay. So let's just concentrate on this. Let me just see if that's right. 1/3 times an minus 1/3. Yeah, that's right. Okay, so Sn, which is a whole bunch of b's being added together, but they're consecutive. I don't know if that helps that they're consecutive, but that's Sn. Okay. So let's just do a few using this formula. So that's going to be 1/3 a1 minus 1/3 negative 1 to the power of 1, right? And then we have b2, which would be 1/3 a2 minus 1/3 negative 1 to the power of 2. And I'm just going to write one more, 1/3 a3 minus 1/3 to the negative 1 to the power of 3, and then you guys get the idea. Okay, so what we can do is group this. The first thing I'm going to do is factor out a 1/3 and just put all the a's together. So a1, a2, a3, ... like that. And then I'm going to factor out the 1/3 and see what I have left. It's going to be negative 1 plus 1, negative 1 plus ... like that. Let me just see if that is correct. I think so. Yeah. Okay, well, the A1s we know. Those are just... actually, we did need to know this. It's just powers of 2. So it's going to be 1/3 times 2 plus 2 to the power of 2 plus 2 to the power of 3, ... like that. And then minus 1/3. This one, I don't think there's much I can do other than just writing it out again. Okay, so now, what do we do now? Okay, I think they was giving us some information. Yeah, this stuff here, that was given for a reason, because we have to use it. The first n terms of a geometric sequence with the... okay, I got it. And that formula is going to be coming into play. So we're going to use that on this guy here. So the 1/3, and then if I use that formula, I can combine those. Let's see here. 1 minus r to the n. So 1 minus r in this case is 2, because that's the common ratio between each of these terms. If you go from this guy to this guy, you're just multiplying by 2 every time. So the common ratio is 2. So 2 to the power of n minus 1 minus 2, using that formula. And then minus 1/3 this guy. All right, is there anything I can do with this guy here? I don't think so. I wish there was, but maybe later there'd be something I can do with it. Okay. If I simplify this guy, I think I just get 1 minus 2n, and then, let's see here. 1 minus 2n. Oh, I forgot the first term. This guy right here. This a, don't forget that a. The a is the first term, which is 2. This is the first term. I gotta put that out there. Okay. Make sure you don't make that mistake. Okay, so it's 1 minus 2n. And then I believe it'll be negative 2 over 3 if I put everything else. Yeah. And then this one, again, not much you can do. Okay. All right, so now at this point, there's two scenarios here. The first is if n is even, and the second is if n is odd, because it will depend. If n is even, then this whole guy will be negative 2/3, 1 minus 2n. That part doesn't really change, but if n is even, this part becomes 0, I believe. So you just get left with that. Yeah. Like, for example, if n was 2, you would just have those two guys, and they would cancel out. If n is odd, then this part stays the same, minus 2 over 3, 1 minus 2n, like that. But then if n is odd, for example, it was 3, there'd be a negative 1 in there, so you'd have to add on a 1/3. Yeah. Okay. All right, I think that's progress, perhaps. Okay, so now where do we go from here? We got to go back to what they're asking. They're asking for this guy here. Sn has got to be greater than or equal to 16 to the power of 2021. Okay, not sure where they're getting that from, but they want Sn to be greater than 16 to the power of 2021. Okay. All right. Oh boy. So, well, I guess we have to do two scenarios here. One when it's odd, one when it's even, I guess. Okay, so let's start with the even guy, I think. Let's do this one. That means these were SNs, right? Yeah, I forgot to put in the SN. That's so many. Yeah, these are all SNs. These are formulas for SN, this guy. Okay, all right, so let's put it in. So this is going to be, I'm going to switch this around a little bit, 2n minus 1, just so I have less negatives. 16, 20, 21. Yeah, just make sure that's correct. Yeah, and then the 16 is 2 to the power of 4, right? So I'm going to put that in there because we've got powers of 2 on this side, like that. And then that would be 2 to the power of 8,084, I believe. Yeah, 8084. Yeah. And this is the same, 2n minus 1, 2/3. And then at this point, I think I can get rid of, let's see, what can I do here actually? Let me put just this on one side. So I'll put the 3 over 2 here, 2 to the power of 8084. And then this 2, I can combine with this. This is 2 to the power of 1. So it'll just be 2 to the power of 8083. And then you get 2n minus 1. And is there anything else I can do? I can just substitute it. 2n is greater than or equal to 3 times 2 to the power of 8083 and plus 1. I think that's about as far as I can go there. Okay, so now let's do the odd part. The odd part is 2n minus 1. Again, I'm just getting rid of the negatives. Plus 1/3 this time is greater than, and I'm just going to put this in right in the beginning because you guys know what I'm doing. And then let's see, what am I going to do here? Oh, I'm going to put it on the other side. So 2 is 8084 minus 1/3. And then this is 2n minus 1 and then 2 over 3. Let's put the 3 over 2 over here. And then we have 28084 minus 1/3, like that. And then what do I do now? If I did this correctly, hopefully. I guess I can expand it. 2n minus 1. This is going to be 3 times 28083, very similar to the previous one. And I think this just becomes minus a half. And then finally put the 1 on the other side. So 3 times 28083. If you add 1 to both sides, this becomes a half. Okay. All right, great. So I got this final result and this final result. One is for even, one is for odd. But I've got to combine these. Okay. So 2n is greater than this guy and is greater than this guy. So obviously, let me think about this. So obviously, it's got to be greater than just the 3 times 2 to the 8083. I don't know if that's actually, it'd be greater than that plus 1. Because if it's greater than this number and greater than that number, then obviously it's got to be greater than this one because this number is smaller. I'm just trying to see the logic here. It's like saying A is greater than or equal to 5.5 and A is greater than or equal to 6. So obviously A has got to be greater than 6 if you combine them. But then that one is really bothering me. But let's just get rid of the 1 for now and let's see what we get. Because that 1 is so small compared to this gigantic number that I don't think it'll matter. So let me just get rid of the 1 and just narrow it down to this. And I think I'll be able to come up with an n. Okay, so this should be relatively straightforward. If it's greater than that, then that means it's going to be greater than 2 times 2 to the 8083, right? But if it's greater than the 3, then it's got to be greater than the 2. And therefore, if I combine them, it'll be 2 to the 8084. And therefore, if the bases are the same, the exponents are the same. So therefore, n is greater than 8084. And they want the smallest possible n, and that would be 8085. And I think that solves it. In triangle XYZ, the measure of angle XZY is 90. Also, YZ is X, XZ is Y, hypotenuse is Z. Perimeter is P, area is A. All right. So let's draw the first one. So that's going to be a triangle like this. So we have Z, Y, and X. And this is Y. This is small x, and this is small z, and this is the right angle. So x is 20, and y is 21. Well, I guess A and P. So A is what? The area. So area is 1/2 base times height. So that's going to be 20 times 21. So that is 210. And P is the perimeter, which is x plus y plus z. Now, in order to figure that one out, I need the value for z, which I can figure out with Pythagoras. Z squared is equal to x squared plus y squared. And I'm certain you can do this. 21 squared plus 20 squared. And then when you solve for this, you get z is equal to 29. So this perimeter will be 20 plus 21 plus 29, which is 70. So there you go, 210 and 70. If z is 50 and a is 336, what is the value of p? Okay, so the same kind of story, another triangle. Area, let's just label it again, x, y, and z. So the area is 1/2 base times height, and they're saying that's 336. And z is 50, okay? Z is 50. All right, and what are they asking for? P. So they want you to figure out x plus y plus z. And x plus y is what we don't know, but z they gave us is 50. Okay, kind of interesting here. All right, so we got to use a little bit of algebra. X plus y squared, you guys know, is x squared plus 2xy plus y squared, right? Well, x plus y, we just, I don't think we know that yet. Yeah, we don't know that. So, well, if I rearrange this a little bit, I get x squared plus y squared plus 2xy. Now, x squared plus y squared is z squared according to Pythagorean theorem applied to that triangle. And then 2xy I can get from this guy. If I multiply both sides by 4, I will get 2xy over here. And 336 times 4 is what I'll get over there, which I believe is 1344. Okay, so 1344, and then z squared, well, z is 50, right? So that's 2500 plus 1344, and that's going to be 3844. So if I take the square root of both sides, I'll get x plus y is equal to the square root of that, which is 62. And what are they asking for? Oh, okay, I just plug it in here, and okay, I got it. So a little bit of A little bit of algebra there to get the final answer. Determine all possible integer values of x, y, z for which a is equal to 3p. All right. So a is equal to 3p. A is equal to 3p. Okay, so area is equal to 1/2 base times height, and the perimeter is x plus y plus z, correct? Okay, now where do we go from here? I think, well, first let's get rid of this fraction. So we have xy is equal to 6, x plus 6y plus 6z. And then let's see what we can do with the Pythagorean relationship. So we're going to have to put this on the other side, 6y, 6x like that, 6z. And then let's square both sides. So x minus y, 6x, 6y, because that will allow me to get a z squared in there. And then when I expand this out, I'll get xy squared minus 12x times xy minus 12y times xy plus 72xy plus 36x squared plus 36y squared is equal to 36. But z squared, I'll put x squared plus y squared, and that will hopefully help us. Okay, now let's see what I can do. Oh, I think some stuff cancels out here. This is really nice. This 36x and this 36y cancels with that. Oh, okay, that's really helpful, I think. And let's factor out the xy. So I'll get xy minus 12x minus 12y plus 72, and that equals 0. Okay, I think this is going somewhere. And then I can get rid of the xy and just have this left. A is equal to 0. Okay, I think at this point we got to use a little bit of fancy algebra. We got to add 144 to both sides here. Yeah, and when you do that, it will allow you to factor. So if I factor out an x, I'll get y minus 12, and then minus 12y. Let's see here. And then plus that 144. And then if I bring the 72 over to the other side, it gives a 72 over here. And then I can factor out a 12 minus 12, and I'll get y minus 12. I see. Okay. And then I can factor this y minus 12, x minus 12. Got it. Okay, so that is a good result. That's a good result. So, okay, so that basically means we got to make a table, and we can figure this out now. So we have y minus 12. We have x minus 12. We have x, and we have y. And then what else? Z, which is basically x squared plus y squared, taking the square root. And then our x, y, z triplet. Yeah. There we go. Okay, so we have two numbers, y minus 12 and x minus 12, and when they're multiplied together, they give 72. So what are our possibilities? Well, I don't know. You can have 1 and 72. If this is 1 and this is 72. So if that's the case, then x would be 13 and y would be 84, I believe. Yeah. And then z, you guys can do that. That'll come out to be 85. And therefore our triplet would be 13, 84, 85. But y and z are interchangeable, so it could also be 84, 13, and 85. And similarly, you'll get other numbers, like if this was, let's see, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9, I believe. Yeah. Like that. Like that. So that means x and y, we got 14 and 48. We got 15 and 36. 16 and 30. 18 and 24. 20 and 21. And then the z's are going to be 50, 39, 34, 30, and 29. And then you guys can figure out the pairs. Just remember that for each one, the x and y are interchangeable, so you can get 2 triplets for each of those guys. Suppose that x, y, and z are integers. P is 510, as a is kp for some prime number k. Determine all possible values of k. All right, so again, same kind of story here. A is, they're saying, is kp, and we know that a is equal to 1/2 base times height, and that's equal to kp, and k is x plus y plus z. So it's very similar to the last one. The only thing is that we have a k here instead of a number. So this will be 2k x plus y plus z. So we got to do a whole bunch of fancy algebra, and I will show it to you. So here's the algebra that you had to do when it's all said and done. As you can see, you're going to put in P as 510, and that's pretty much the perimeter. That's this guy. And then you isolate for x, y. Or rather, isolate for x plus y. And that's going to be 510 minus z. And then square both sides, and you get this big long thing. And then isolate for 2xy. And remembering that x squared plus y squared is equal to z squared. And that allows you to cancel that out. And then remember that xy is equal to, a is equal to 1/2 xy. So you multiply both sides by 4, you get that 4a is equal to 2xy. And that's pretty much what they have there. And then at this point, they tell you that a is equal to kp, but p is equal to 510, so you can put in that 510k. And then divide through by 510, I believe, and you can probably divide through by a 2 times 510, and you'll get finally this guy. And then you substitute back the value for z, which would be 510 minus x minus y, and then you arrive at this final equation right there. That x plus y minus 2k is 55. Then we'll go back to the original formula that we were given, that a is equal to kp. So a, which is 1/2 base times height, is equal to k times x plus y plus z, because p is the perimeter. And that's what this is. This is your basically, remember a is equal to kp. So 1/2 base times height is equal to k times x plus y plus z. And then, of course, if you multiply both sides by 2, you'll end up with this guy. So then we got to do some fancy algebra, and that's all this is. This is a whole bunch of algebra. And it's very similar to the previous part where you had to square both sides, blah, blah, blah. And when you do, you finally get to this guy right here. So we have this result, and we have this result as after some significant algebra there. So let's write those two findings. We have that x minus 4k and y minus 4k is equal to 8k squared. And we have our other finding that, what was it? X plus y minus 2k is 55. So x plus y minus 2k is 255. Okay. So from this guy, I make a little table on the side, x minus 4k, y minus 4k. And the possibilities to me look like 1 and 8k squared, 2 and 4k squared, 4 and 2k squared, 8 and k squared, k and 8k, and 2k and 4k, I believe. And as always, I think it's interchangeable. Okay, so that takes care of that. But we actually have a big long table to make to get our values for k, which are going to be prime numbers. We are going to look at x minus 4k and then y minus 4k, right? So we've got that already. So I don't think I need to put it in again. Let me just extend this table right here. Okay, so we got those. Then of course we're going to be able to figure out x and y. And then this will allow me to figure out that famous x plus y minus 2k is 255. And that will allow me to figure out the value for k. So I'm going to do, well, let's see what we get, if there's any solutions, because I don't think some of these will even have solutions. That's what makes this hard, because you're going to have to do a lot of algebra to find nothing. But hopefully there'll be at least a couple solutions. So first one, this times this is equal to 8k squared. So one possibility was 1 and 8k, right? 8k squared, I should say. So that means that x is equal to 4k plus 1, and y is equal to 8k squared plus 4k. And then when you substitute that into here for x and y, you'll get 8k squared plus 6k is equal to 254. Yeah. Now, this will not give you any solutions for k that are prime, so no solution. Similarly, this guy will also give you no solutions, and this guy will give you no solutions, and this one gives us no solutions. But these ones do give solutions, and let me show you. So this one is going to be 8 plus 4k, I believe, and this is k squared plus 4k, and when you put it in this equation, it becomes k squared plus 6k, so I'm going to factor it to make it look a little bit easier. And therefore, the k will be able to have a solution that is prime, and that's 13. And then finally, this guy, the k and the 8k, I believe this becomes 5k, 12k, and these are some of the distances I run. And this becomes 15k is equal to 255, and k equals 17. So there we go. We did eventually get two solutions that are prime.